Hello, this is Dr. Frost. Just before we begin, just to note that you can practice questions interactively on this topic, including past paper questions, just by going to www.drfrostmaths.com/homework. Feel free to pause the video any time, whether just to digest the new material or whether to do one of the test your understanding questions that I'll be setting you throughout the video. Now let's begin. Now in this final part of trigonometry, I want to discuss something that's just been added to the GCSE syllabus, and it's how we can find sine, cos and tan of kind of common angles. We'll see why in a second why I might consider these to be common angles. But how do we find, for example, cos of 45? How do we find tan of 30 without using a calculator? So this could occur in a non-calculator paper. Now you might think, why are these values significant? Where might we see an angle of 60 or where might we see an angle of 45? Well, 45 we might see if we have like a square, and then I'm going to put dotted lines here, and then I split it in half. Well, what angles would I see in this half a square? Well, I would see, well, we've got 90 here, and you would see 45 degrees here, wouldn't you? Because that's just half of 90. So we can see here that 45 has a special significance because it's just the angle within half a square. And 30 and 60, where might we see these? Well, 60 degrees, we'd usually associate that with an equilateral triangle. So if we draw an equilateral triangle, this, and I'm going to do the rest of the dotted line, you'll see why in a second. Now we know this angle is going to be 60 degrees, and in fact if we split this in half, then we can see that angle is going to be 90 degrees, and that angle here is going to be 30 degrees, isn't it? Yep. And using these triangles in trigonometry, we can actually find sine, cos and tan of these various angles we see here. Now, we don't have any lengths, do we? So we can just come up with sensible lengths, and it won't really matter because these are trigonometric ratios. So like how many times bigger one side is another. So I can make these sides anything I like, and we'll still get the same value of sine of 30, etc. So just for simplicity, I'm going to make this side 1. So it's a square of side 1. And then how would we find this side? Well, we can just use Pythagoras, can't we? So this side here, it's going to be that squared plus that squared and then a square rooted. So 1 squared plus 1 squared, that's 1 plus 1 is 2, square root that, and that length there is going to be 2. And what about this equilateral triangle here? Now I'm going to make this shorter length 1 here. And now we can see that's half the length of the equilateral triangle, half the side, so that would consequently be 2. And then very quickly doing Pythagoras theorem again to find this third side here, well, we're finding a shorter side this time, so it's actually going to be that squared minus that shorter side squared, and then a square rooted. So we're going to do 2 squared, which is 4, minus 1 squared, which is 1, 4 minus 1 is 3, and then we square root that, and that's going to give us root 3. And we have these two constructions here, and it is worthwhile remembering how to draw these two triangles because these will allow us to work out all the values that we have here. So now, once we've got that, let's draw a table of what we need. So we want to find what sine is, cos is, and what tan is, these various angles. And I'm going to put 45 first, 12 degrees, and then I'm going to put 30 degrees, and I'm going to put 60 degrees. There's a reason why I've broken the table up like this. Well, it's just because this is related to this diagram, and these two are related to this diagram. So let's firstly get sine of, say, 45. Well, sine of 45, we know sine is, thinking back to SOHCAHTOA, sine is opposite over hypotenuse. So let's try and do this mentally. Sine of this angle is the opposite. What's opposite to this angle? It's over here. So it's the 1 over the hypotenuse, which is root 2. So sine of 45 is consequently 1 over root 2. Next, let's do cos of 45. So cos of 45 is the SOHCAH, so it's adjacent over hypotenuse. So it's going to be the adjacent, which is 1. The 1 is adjacent to that angle, over the hypotenuse, that's 1 over root 2 again. So in fact, the same value. And then finally, we've got tan of 45. Tan of 45 is opposite over adjacent. It's SOHCAHTOA. So tan of 45 is the opposite 1 over the adjacent 1. So it's just going to be 1. So tan of 45 is 1. And now let's go on to sine of 30. So we're going to look at this diagram now. So sine of 30 is going to be the opposite over the hypotenuse. So it's the opposite 1, because 1 is opposite the 30. Opposite over the hypotenuse, the 2's there. That's going to be half, isn't it? So we've got half. Next we've got sine of 60. So this time the opposite and adjacent change where they are. So we're going to do sine of 60. It's the opposite to the 60 this time. So it's root 3 over the hypotenuse. That's root 3 over 2. Sorry, that's not so clear. And then cos of 30. That's going to be adjacent over hypotenuse. So it's adjacent to the 30. So the root 3 is adjacent to the 30 over the hypotenuse, which is 2. So it's root 3 over 2. And then we've got cos of 60. So cos of 60 is going to be adjacent to the 60, which is 1 over the hypotenuse, which is 2. So that gives us 1 over 2. And then finally, we've got tan of 30 and 60. So we've got tan of 30. So here's the 30. It's opposite over adjacent. So where's the opposite? It's 1 over the adjacent, which is root 3. So it's 1 over root 3. And then finally, tan of 60. So let's look at the 60, put our finger on the 60. It's the opposite, which is root 3. Root 3 is opposite the 60 over the adjacent. So it's root 3 over 1. Well, when you divide by 1, it doesn't really affect it. So it's just root 3. And those are all the values you basically need to work out using these kind of special triangles here. And I've actually got a nice little memory tip. I just remember in this block here, whenever you have a surd involved, when it's 45 degrees, it always involves root 2. So sine of 45 and cos of 45 are both 1 over root 2. So these are over root 2. And tan of 45, you just have to remember, is 1. But this block here, block of 4, I just remember all these 4 here are over 2. They're all over 2. And I remember that this diagonal here, those are the ones not involving surds. So they're both half, and the other 2 do involve surds, and they both involve root 3. And I just remember, well, we haven't gone to trigonometric graphs yet, but I remember from the graph that tan of 30 is going to be less than tan of 60, and 1 over root 3 is smaller than root 3, and that's how I remember which way around they are. So that's just a way to remember these, kind of try and picture this table in your head. Now, what we're going to then do is then kind of solve questions involving these exact values here. So I've first got this question here. And we've got this here. We've got this triangle, we've got this 60-degree angle, we've got that 8, and we want to work out what x is. So, let's do this. We're going to label some of these sides again, so I'm just going to actually copy out very quickly. So that's 60 degrees. We've got 8x. And let's do what we usually do. We kind of label our sides. So this is adjacent to that angle. So we're going to put an A here. And this is the hypotenuse. So that is SOHCAH. So it's cos. So we're going to do cos of 60 degrees is equal to the adjacent over the hypotenuse. So it's the x over 8. And we're going to do what we usually do. Well, we want to get x on its own. We don't want to have that divided by 8. So we times both sides by 8 to get rid of the over 8. So it's going to be 8 cos of 60. And that is equal to x. And then we can look back at these exact values, and we know that cos of 60 is half. So that's just 8 times half. So 8 times half is equal to x. And that means that x is equal to 4. So we've got that one. and I'll just do a second one quick, and then I'll get you to do one yourself. So we've got this example now. We've got this triangle here, and we've got a 45-degree angle here now. So if I'll quickly copy it out just so I can put I can label the sides. So that's 45, that's y, that's 3. So we've got, this is the opposite this time, and this is the hypotenuse. So it's going to be SOHCAHTOA as SO, so it's sine. So we've got sine of the angle 45 is equal to the opposite 3 over the hypotenuse, which is y. And as I've mentioned in my previous videos, we can use the swapsy trick, so we can swap these two to get y is equal to 3 over sine 45. Now this one's a bit harder when we put it in. So we sine of 45, we can see sine of 45 is 1 over root 2. So it's 3 divided by 1 over root 2. Now it'd be quite nice to sort of tidy this fraction up. We don't want a fraction within a fraction. So what could we do to the top and the bottom to tidy this up? Well, we could times by the denominator of the inner fraction. So if I times top and bottom of this fraction by root 2, well, if I times 1 over root 2 by root 2, you're just left with 1 because it cancels out the over root 2. So if I times top and bottom by root 2, that just becomes 1. And the top, when you times it by root 2, becomes 3 root 2. And we know when we have something divided by 1, we don't really have the over 1. It's just going to be 3 root 2. And we have that there. And that's the answer to that. Now, time for test your understanding. So I'm going to leave a question here for you. And if you want to pause the video and have a quick go at this question here. Right, hopefully you've had some time to do that. So let's do this. We've got this triangle here. We've got the 30, we've got the 6 here, and we want to find AB. So let's just call it X. That is the opposite. And that is the adjacent. Now, what do we use there for? SOHCAHTOA, it's tan. So we've got tan of the angle is equal to the opposite x over the adjacent 6. We can just times both sides by 6, so we've got 6 tan 30 is equal to x. And then tan of 30, if we look back at this table again, we can see that tan of 60 is, tan of 30 is 1 over root 3. So it's 6 times 1 over root 3 is x. And that we could just write as well. Remember, when we times a fraction by a non-fraction, it's just the top that's effective. So we could write that as 6 over root 3 equals x. Now, to finish off with, I want to look at this particularly hard problem from an Edexcel mock. And I know many of my students struggle with this one. We've got this construction here where we've got 3 right-angled triangles joined together. And we've got this side here, y, on this triangle with a 30-degree angle in it. And we've got these 3 triangles attached together. And we've got this n over here. And it says that given that y equals kn, find the value of k. Now, what effectively that's saying is, well, y is k times n. So we want to find how many times bigger y is than the n over here. Now, there's quite a lot of steps to this problem, but if you just break it up into bits, it's not quite so horrible, even though there's quite a lot of technical detail. Basically, the strategy is to realise that, say, this triangle and this triangle have this side in common. So it might be a good idea to sort of start with this triangle here, and use trigonometry to work out that side, because we can then use that length in this triangle and use trigonometry again to find this side, and then we have a way to connect this side and the n. So let's do it. I'm going to draw first the triangle on the right. So we've got here, if I do it over here, we've got this. We've got this 30-degree angle, and we've got the y here. And we want to find this length here because that length's going to then be used in that second triangle. So let's give it some label for the moment. Just say x. So we've got the x there, and we're going to use trigonometry. So this is opposite to that particular angle, and this side here is the hypotenuse. So that is SOHCAHTOA, it's sine, isn't it? So we're going to do sine of the angle, 30 degrees, is equal to the opposite y over x. Now, we want some expression for x, because we're going to then subsequently use x in this triangle. So we need to use, well, let's work out what sine of 30 is. We know from our table that that is half. So we got half is y over x. Now, when you've got a fraction on both sides of the equation, we can use something called cross multiplication. And the way that cross multiplication works is to say that that times that is equal to that times that. So we've got 1 times x, which is x, is equal to 2 times y, which is 2y. So we now know that x is 2y, and we can now focus on this second triangle. So let's do that. I'm going to draw the second triangle. And we've got this 30-degree angle here. We've got this side down here, which we now know is 2y. And we want to find this length because this length is then subsequently used in that last triangle. So I'm going to give it a different variable letter. Let's just say z. And we can use trigonometry in exactly the same way again. So this side is adjacent to that 30. And this side is the hypotenuse. Yep. And then that's going to be cos, because it's SOHCAH. So we're going to say cos of the angle, the 30, is equal to the adjacent 2y over the hypotenuse, which is z. And then let's find out what cos of 30 is. Well, we can look in our table, and we would see it's root 3 over 2. So root 3 over 2 is equal to 2y over z. And then we can cross multiply again. So we've got root 3 times z is root 3z is equal to 2y times 2, which is 4y. And we want to make z the subject because we want to have expression for z that we can subsequently use in the last triangle. So let's divide by root 3. So we've got z is 4y over root 3. Now we're nearly there. We can now work on the last triangle. So if we look at this diagram again, we've got, this is the last triangle on the left. And we've got 30 here. And we've got the n there. And we now know this length here, which we worked out was 4y over root 3. Yep. So we do what we usually do. We label these sides. So that is opposite to that angle. And this is the adjacent. So what do we use? SOHCAHTOA, it's going to be tan. So we do tan of 30 is equal to the opposite n over the adjacent, which is 4y over root 3. Now again, we've got a fraction within a fraction, and we don't really like that. So what we do is, as I said before, times the top and bottom of the outer fraction by the denominator of the inner fraction. So we're going to times top and bottom by root 3. So the top then becomes root 3n when we times by root 3. And when we times 4y over root 3 by root 3, that gets rid of the over root 3. So we have 4y. And we know what tan of 30 is. It's 1 over root 3. So we've got 1 over root 3 is equal to root 3 n over 4y. And what do we want to do here? Well, if we look back at the original problem, we want to get y in terms of n. So we want to make y the subject here. So we're going to do what we usually do. We can cross multiply. So 1 times 4y. So we've got 4y is equal to root 3 times root 3n. Now, if you've done surds before, you will know that root 3 times root 3 is just 3. So we got 4y is equal to 3n. And then we want to make y the subject. Y is kn. So we can just divide both sides by 4. And we get y is 3n over 4. Or we could write that as 3/4 n. And because y is kn, that means that k is equal to 3/4. And we're done.